DHCP Secure here. Today I wanted to talk about DHCP and DHCP snooping on a Cisco iOS switch. So in this video we're going to go over DHCP, which is Dynamic Host Configuration Protocol, which is a way for a machine to receive an IP from a DHCP server. In our case, we're going to use our switch as that server. So besides receiving an IP address, a DHCP server can also serve out other features like DNS servers and special DHCP options. So to start, we need to decide if the network range we want to serve IPs should have any IPs that are excluded from that range. So in my example, what I'm going to do is I'm going to make switch 1 my DHCP server, and I'm going to exclude the first 1920 IPs from the list. So to do that, let's pull up our switch, go into global config mode, and the command to exclude IP addresses is IP DHCP excluded address, and then the address range. So I'm going to do 10.10.10.1 to 10.10.10.19. So my first IP should be 20. Alright, I'm going to save some time, just copy over some of the other excluded ranges for our other subnets we'll create. Alright, now that the exclusions are created, we can create our DHCP pool. Now the global configuration command for this is IP DHCP pool, and then the name we want to give it. So in my case, I'll do data network. And one thing I've found is kind of helpful if you just want to use like this name for everything that's data, maybe appending it with the network. So 10.10.10.0/24. Alright, so now there are only two things that are needed for DHCP pools to serve IP addresses. And the first one is the network command, and then your network, so 10.10.10.0, and then your subnet mask, 255.255.255.0, and the other command is the default router, and then your SVI, your gateway, so 10.10.10.1. So these assign the networks to use, and the default router gives the gateway to the computer so it can get to a gateway. So, like I said, this is all that's necessary to make a computer get an IP and be able to access the gateway or your network. Although there are a few other useful commands, especially for an endpoint, such as your DNS server. And that command is DNS-server, and then you have to give it the IP. Since I don't have one in my network, I'm just going to make up an IP address. And the other one is a domain name. And the command for that is domain name, and then your domain. And I'm just making up one. So now you will tell the server, or your endpoint, what DNS server to use, and then what domain name to, add to its queries. So now there is one other option you can do, and that's your special DHCP options, and that's using option, helps if I can spell, option, and then the option number. So one common one is for like TFTP, for like call manager, like if you're going to have a phone, option 150, or even like option 43, I think it's 43 for access points. And then you can give it, the IP address, IP, and then the actual address, or, if you wanted to do it in hexadecimal, you can do that. Or if you wanted to give it like an ASCII string, certain ones need that, you just would do it this way. And I'm not going to do the option 150 just because it's not needed for the data network. Now I'm going to add my other DHCP pools by copy pasting it, and I will make note that for the voice network I did put in the option 150. Not that I have an actual, call manager environment stood up here, but this is just so you'd see that this is how you would do it. All right, so DHCP is all set up. Now to verify that things are working, once that the scope is now built, I'm going to switch to one of my endpoints and see if I get a DHCP server or DHCP IP assigned. And here we can see it's doing what's called DORA, the discovery offer request acknowledge. And there we go, we have an IP. So I should be able to ping my gateway. And I can. Let's see now if our other scope is working on the server subnet. And alright, that's good. So we should be getting another IP. Let's see if we can ping our other endpoint. And we can. Now we can also verify this on the switch using the command show IP DHCP binding. And now we actually have a couple entries here. So we can do that to the rest of the, well, we'll do it to one more. And we should see it then showing up in our table. Make sure we get the offer. So now, there it is. So now we're going to build a scope for VLAN 10 that sits on switch 4. So that sits over here. Switch 4 doesn't have, we're not going to build it locally. We're going to keep it on switch 2. But this doesn't have access to our DHCP server via a layer 2 connection. But it does have access through a layer 3 connection, so it's IP based. So since it doesn't have local access, it will need to send a relay message to switch 1. So to configure this relay, we will use the command on the SVI of the VLAN on switch 4 to point to switch 1. So let's hop on switch 4, go into global config mode. So we have to do it on the SVI. Let's just make sure we know what the VLAN is, and it's going to be VLAN 10. So we're going to go to interface VLAN 10. Now the command for the relay is IP helper address and then the IP of the DHCP server. And I'm going to use the management IP. And that is it. So now we should be able to hop on our computer 7 and do IP DHCP. Alright, that's good. We're getting the offer and the request. So now we should see it show up in the binding table. There it is. And we should now have access to everything here as well. So let's see if we can get to that endpoint. We can. Alright. Well, let's see if we can get to the server, and we can. Alright, so DHCP is configured throughout our environment. Now, a useful command to secure our DHCP infrastructure is the DHCP Snooping configurations. What this does is protect the DHCP processes from like rogue DHCP servers. So if someone plugs in their rogue DHCP server, what they could do is tell an endpoint that the gateway is actually a rogue server, so it can then begin performing man-in-the-middle attacks. So with DHCP snooping, a table is created that helps some of our other security features that we'll cover later on, such as dynamic ARP inspection. But to enable DHCP snooping, we need to tell the switch which VLANs to snoop on. And that's done in global config. So we'll actually hop on switch 2 and type config T to go to global config mode, and then IP DHCP snooping VLAN, and then like I said, we have to tell it which VLANs we want to do. So 10, 11, and 20. Alright, we then need to make sure to tell the switch which ports to trust DHCP packets on. Otherwise, DHCP won't work. But once the interface is known on that, that the interface command IP DHCP snooping trust is required. So let's just see what our trunk is to switch 1. And that should be port channel 12. So we're going to do IP DHCP snooping trust. just to be safe, I do want to make sure that it got pushed down to our actual interfaces. Okay, it's on 3.2 and it's on 2.2. Okay, so IP DHCP Snooping Trust got pushed down to the port channel, which sent it to our two physical interfaces, virtual interfaces in this instance. So now we can actually turn on IP DHCP Snooping. And that command is a global config command, and that is IP DHCP Snooping. Now, in many cases, one more command is needed, and that is the no IP DHCP Snooping information option. Now, this command generally needed as switches will send some other data to DHCP servers with that option, and it doesn't work properly, especially with Microsoft DHCP servers. So I just recommend just putting that command in. Now, to make sure that DHCP snooping is working, we can do show IP DHCP snooping, and we see that it is enabled on 10, 11, and 20. It's operational for 10, 11, and 20, and that we have trusted these ports. Another good command is show IP DHCP snooping statistics. Right now there's no traffic, so what we're going to have to do is we'll hop on 4, since I already did IPD. We can do it again. We'll do that again there, and we'll actually do it here. So both computers that hang off of that switch 2, 3, and 4, should send the DHCP requests. So there it is there, and there it is there. So now, if we show that same command with statistics, we have forwarded 10 packets. And now the final command, this is probably the nicest command, is the show IP DHCP snooping binding. So this shows the binding table of what IP address is assigned to which MAC, the interface it's on, the VLAN. A lot of good data here. A lot of the times a network team might not have access to the DHCP server, so you might not know the MAC to IP mapping without doing, like an ARP command. So this is a nice one to be able to see all of that information, because you might not always have access to the DHCP binding table. Alright, that completes our video on DHCP and DHCP snooping on a Cisco switch. In the next video, we're going to review some more security features, namely port security. Thanks everyone for sticking around.